Central angles and angles involving chords and tangents of a circle. Okay, so we have to review a couple of words here. So we have central angle. So central angle, and we've covered this one before, and they're just doing it down here. So I'm going to use this diagram because it's a nice little pretty one here. So we have a central angle. It means that you have the vertex of the angle you're talking about is at the center of the circle. And then you have your two rays, or in this case, line segments going out, and they are creating the angle. And that captures this arc. So if you know what the central angle is, you know what the arc are because they're the exact same. A central angle is equal to the arc is equal to the central angle. So that one's generally pretty easy. Then we have an inscribed angle, and usually an inscribed angle looks like this, where we have it going like this, but it goes to the side. Instead of the center of the circle, it goes to the side of the circle. That's where the vertex is. And then this is the angle, or the arc, that's captured by the angle. So with this one, whatever the angle is, the arc is twice. So if this is x, this would be 2x. So you can kind of go back and forth with that. If you have the angle, you multiply by 2 to get to the arc. If you have the arc, you divide by 2 to get to the angle. So this is one we've learned previously. Well, now we have a chord tangent angle property because that's the situation that we're dealing with. So a chord is a line that goes from side to side of this circle, but it doesn't go through the center. So you notice it's not by the center here. So it goes from side to side. And then if we have a chord that intersects the tangent, exactly where the tangent crosses the circle, that's another one that we've learned just recently. A tangent grazes the circle or touches the circle at one point. So the chord has to intersect that one point, so it has to cross that one point. And then we have the exact same relationship we do with an inscribed angle, which is why I brought it up. So in this case, they have it backwards. Instead of x and 2x, they have x and 1/2 x. Same relationship. This is just talking about dividing the arc by 2. Instead of me talking about you have the angle and you multiply by 2. Same type of idea. So in this one, the red portion here is the arc that's kind of intercepted or captured, if you can kind of think of that. Like you have your point and then you come over here to your other point. So this is the arc that it creates. So if we know the degree of that arc, we can divide by 2 to get to the angle. If we know the angle, we just multiply by 2 to get to the arc. Okay, so it's that same idea of inscribed angles that we've already dealt with before. I'm going to erase this stuff and scooch down. So for this first one, if we want to find FG, which they have highlighted here in red, then we just need to know what the angle is. And they told us, I do believe that was given information, that angle FEG is 128. So we already knew this angle here, which they have marked with the green, this angle is 128. Well, it's a central angle. So if I know the central angle, I know that the arc is exactly the same. That's why they're saying the arc is equal to the angle, which is equal to 128. All right. Now, if we're looking for angle GFH, which they have again marked out in green here, then this is the chord tangent situation, or the inscribed angle relationship. It's that same relationship. So we know that if we have the angle, which, let's see, which one do they give us? Oh, we have the arc because we just marked that. 128, we found that. So I know the arc. I'm going to divide by 2 or multiply by 1/2, means the same thing, to get to the angle. So the angle is 64 for this angle right in here, like this. The 64 degrees. All right, so those are the two new things that we're doing for this one. So let's go ahead and start so we can see from beginning to end how it's worked out. So let's go ahead and mark some of these. We have QPR. So this angle here is 100. Darn it. Started to write that really funny. 104. I don't know why it doesn't like my 4s on this one. 104. So we have 104 degrees here. And then it also tells us that QS is a tangent to the circle. So we know right away that if it's a tangent, it only touches the circle, or you can think of it kind of like as a graze. It goes right past the circle at 1 point. So now what we want to do is find the different arcs they're asking us about here. We have, the first one is arc QR, so this arc here. And remember, QPR, so QPR, I'm marking that out in blue so you can see. The green arc is what's created by angle QPR. It's a central angle, so that means that arc QR is exactly the same. It's 104. Okay, and now we're going to look at angle RQS. So this angle down here, RQS. So they're intercepting the same green arc. But remember, when I go from a chord to a tangent, that's got its own property. It's half the measure of the arc, which is the same thing as an inscribed angle. So I'm going to go 104, and I'm going to divide by 2, and I get 52. All right, 52, check. All right, next. So now we're going to go with KL. So now they're giving us this arc is 52 degrees. And then they also tell us that KM is a tangent. Again, that means that it only touches the circle at 1 point. Doesn't go into the circle at all. So we want to first find KJL. KJL. So that's this angle here, which if we follow this KJL like that, so KJL, that is what creates that 52-degree arc. It's a central angle. The arc and the angle will be the same. So angle KJL is 52 degrees. Now they ask us to look at, turn the pen tool on, LKM like this. And I know I'm getting a little bit messy there with the arc is getting a little mixed up, but it's the same arc here going from L to K. So remember, this is chord to tangent, which means the arc is twice as long as the angle, or not twice as long, twice the degree of the angle. So we want to divide by 2, and we get 26 there. Check. All right, let's do one more. So now we have VUW, so this angle here, I'm just going to put it over here, is 46 degrees. And then again, they're telling us that UW is a tangent to the circle. So they're giving us that information because you need that information in order to move forward. If you don't know that it's a tangent, you can't use the chord tangent property. You can't use that, the 1/2 property thing that we've been doing. All right, so we want UV. So I want this arc. Darn it, I did that really ugly here, but I want this arc here. And remember that one I marked out in orange there, that was VUW. So that's arc is created by this angle, or it's captured by this angle. So we know the angle, and this is the chord and the tangent. So instead of dividing by 2, I need to multiply by 2. Saying 2 too many times. I wrote a 2, and that should have been a 6. So we're going to multiply by 2, and we're going to get 92 degrees. So this is 92 degrees on that first one. Let's go ahead and type that in so I can clear this out. Click clear. Okay. And let's find the last one here. So we have UTV. So they want to know what this angle is here. And remember when we did the arc, that was that light blue color that I had there. And we just said that this is 92 degrees. If this is a central arc or central angle, the arc is equal to the, sorry, that looks like a 0. That's a degree sign. The central angle is equal to the arc. So this is also 92 degrees. All right, we finished another one, yay.